Hello everyone, I am Akhilesh, roll number 3 of CSE, and today I will be explaining to you routing protocols. So routing protocols are basically the backbone of how internet communication work, and I will be explaining to you 3 major routing protocols today. Those are RIP, OSPF and BGP. So I'll be explaining how they work, their key differences, and wrap it up with some practical insight on how they're implemented in the real world. So let's get started. So before diving into the specifics, let's try to understand what exactly a routing protocol is. So routing protocol is like, it's a GPS for data packets. It helps them to find the best path through a complex network to reach their destination. So routing protocols ensure efficiency, reliability, and speed in data transmission. First up, I'll be explaining to you RIP. So RIP is Routing Information Protocol, and it's one of the oldest protocols. It was introduced in the 1980s, and it works on the principle of distance vector routing. So here are the features of RIP. RIP uses hop count as its metric, which means that it chooses the route which has the fewest number of hops to the destination. And because of this, it is actually limited to smaller networks, because RIP's hop count limit is 15. So it can only hop up to 15 times, and the router configuration has a limit of 16 routers. So that is why RIP can only be set up in smaller networks. And RIP also updates its routing table every 30 seconds. And after that, it broadcasts all its updates to all the routers. Now I'll be explaining to you the advantages of RIP. So like I said, RIP is suitable for smaller networks. So because of that, it's small and easy to set up. And the disadvantages of RIP are that it has a slow convergence time, and it's inefficient for large and complex networks due to the 15 hop count limit. Next, I'll be explaining to you OSPF. So OSPF is the open shortest path first, and it's a more complex and advanced protocol as compared to RIP. So OSPF uses link state routing, and it provides a comprehensive view of the entire network topology before traversing. So unlike RIP, which has the hop count limit, what OSPF basically does is that it has the Dijkstra's algorithm. So it is the shortest path, it's a shortest path finding algorithm, and using this algorithm, it basically calculates the shortest path and then only traverses it. And this algorithm considers factors like bandwidth and delay. OSPF is also hierarchical, which means that it divides the areas into it divides the networks into areas for better scalability. And it only sends updates when there's a change in the network, so because of that, the overhead is reduced. So the advantages of OSPF are that it's efficient in large and complex networks. It has a faster convergence as compared to RIP, and it supports authentication for secure routing. And the disadvantages of RIP are that it's more because it's for larger networks, it's more complex to configure and manage, and it consumes more power. Memory and processing power. And finally, I'll be explaining to you the BGP, which is the Border Gateway Protocol, and this is a protocol that runs the internet. It is the backbone of global internet communication, and it's the most commonly used routing protocol. So BGP is a path vector protocol, and it's primarily designed to handle routing between different autonomous systems. So before we proceed, I'll be explaining to you what autonomous system is. So an autonomous system, one autonomous system it's a connection of networks, and another autonomous system, it's a different connection of networks. So the thing with RIP and OSPF is that it's an interior gateway protocol, which means it works within the same autonomous system. Whereas BGP, it connects different autonomous systems. It's an exterior gateway protocol, and it connects different autonomous systems. So yeah, BGP can handle routing between different autonomous systems. The key features of BGP are that it chooses route based on policies and preferences, not metrics like hop count, which RIP uses. BGP is highly scalable, and it can handle a vast size, which is why it's used to run the internet, which is a very complex and very large network. BGP also uses TCP for reliable transmission of routing information. The advantages of BGP, like I said before, for large scale networks and ISPs, it is very advantageous, and it's highly customizable through its routing policies. The disadvantages of BGP are that it has complex configuration maintenance, and it has a slower convergence time as compared to OSPF. So finally, before I conclude, I'd like to compare all these routing protocols. So when it comes to scope, RIP is best for small networks, OSPF in a little bit more larger networks and enterprise level networks, whereas BGP runs the internet. It's indispensable when it comes to global internet communication connection. When it comes to efficiency, OSPF outperforms RIP in convergence speed and scalability, whereas BGP stands out in policy-based routing. And when it comes to ease of use, RIP is the simplest to configure, followed by OSPF, and BGP is the most complex. So yeah, to sum it up, I think I've given an overview of all these three routing protocols. All three of them are indispensable and they have their specific uses. And routing and sending packets is what runs the internet. So learning and understanding all these protocols is crucial for network engineers and enthusiasts alike. I hope I've been able to help you. Thank you. This is Akhilesh signing off.